Welcome to the Real Python Podcast. This is episode 19. Would you like to clearly understand what's happening when you use the Python import keyword? Do you want to use modules more effectively to structure your code? Or maybe you're ready to move to the next level with your Django project by adding user management. This week on the show, David Amos is back with another batch of PyCoder's weekly articles and projects. We discuss a Real Python article about advanced techniques and tips for using the Python import keyword. David also talks about another recent article on the site about managing users in Django. We cover several other articles and projects from the Python community, including robot programming in Python, f-strings versus dot format, the rise of Python malware, and more. So let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David. Welcome back.
Hey, thanks for having me.
Cool. So what'd you bring us this week? What are you starting with?
So I've got an interesting article about the return of the Python print statement. Did you ever use Python 2?
Only in passing, partly in the process of trying to learn Python.
Yeah.
Some of the tutorials and some of the stuff I did. And then, of course, the Mac comes with it, up till recently.
Right.
And so it was kind of always there by default.
Yes.
But I didn't study it as much.
Yeah, same. I got in early in Python 3 and never really used Python 2 except for a little bit with Zapier.
Okay, sure.
For a while, they only supported Python 2 for scripting on Zapier. So that was kind of the extent of my use of it. But one of the big things I think people know of difference between Python 2 and Python 3 is the print statement from Python 2 versus the print function in Python 3. And Guido van Rossum, earlier, I guess this is from early June, proposed adding or bringing back the Python print statement. And it's funny because he talks about this and he says this is not an April Fool's joke. He's seriously proposing this. And it's a result of the new parsing expression grammar, the PEG parser.
Yeah, we talked about that.
Right.
I don't know, 6 weeks ago or something.
Yeah, a few weeks ago. Yeah. And he basically just said, I realized that it's only going to take about 20 lines of code to put this in. I had a nice afternoon coding this up and wanted to get people's opinion on it. And it's interesting though, because it's not just the print statement, and it's not the print statement. It's a kind of a different thing, although it looks like the print statement. But as a result of this, what it allows you to do is call a function without parentheses. And it's not just print, it's any function and any method on a class. So for example, the len function that returns the length of a string or of an iterable, you could type, if you have the string ABC, you would do len space and then quotes ABC and it would return 3. Same for a string or a class method. You would just call the method on the class without any quotes and then the arguments separated by commas and get the return value.
That was my question, was like, if you could have arguments more than just one.
You could, and you could even still have keyword arguments. So there's like when you print multiple things, when you pass multiple arguments to the print function, there's like a sep argument that you could print like a separator between those things when it prints. So you could still do like print space and then 1, 2, 3, sep equals plus, and then it would print with 1 + 2 + 3.
Yeah.
So he says, this is I'm proposing this, and I just want to see what your opinion is. But he'd be happy to retract if it's like a resounding boo hiss. This is, and
right.
There's this response. Someone said this is Greg Ewing says, why is this being proposed? I think we would need a very strong reason to consider this. And so far, I haven't seen any justification other than because we can. And Guido's response to Greg was, There was definitely something of that. I was looking at the new pig parser and realized that if people wanted it, this would be easy to do. So I spent a pleasant hour or two coding it up to my satisfaction. But I was also trying to satisfy some demand. When Python 3 was young, print becoming a function was one of the most frequent complaints, and it's still occasionally seen on Twitter. I found at least 2 Stack Overflow issues about it, but the combined upvote count was less than 100. He goes on to say, all in all, it's clear that there's no future for this idea, and I'll happily withdraw it. Anyways, just a funny exchange there, and it seemed like when I came across it, I thought, is this just Guido like reminiscing of the old the old days? Just anyways, funny.
That's fun.
Funny thing. Yeah. What do you got?
The first one I have is follow up from our last conversation 2 weeks ago, talking about malware.
Yeah.
And it's from a website called cyborgsecurity.com by an author, Austin Jackson. And it's an interesting kind of thing. You might think, okay, when I initially started to read the headline, I thought to myself also that, the idea that, maybe there's malware in packaging and you got to be careful about like what you're typing as far as pip installing stuff and, that kind of like namespace pollution or some other kinds of things. And no, it's actually true malware written in Python. One of the barriers to entry there is the idea that Python would have to be installed on the machine. But of course, that whole landscape is changing with things like PyInstaller or Py2xe.
Right.
And you might say, well, it's, malware, one of the things that you would think about is it should probably be small, right? It should be, in the kilobyte kind of range compared to the megabyte range. And, they give an example of, how PyInstaller would create just a simple hello world. And it, jumps from 200 kilobytes for a hello world in like C to potentially, 7 megabytes or more to be an executable on Windows. But 7 megabytes to the majority of people that are out there probably doesn't seem like very much these days. To us programmers, it may seem like a lot. And, people that are, have kind of gone through this transition, but, there's like image files and so forth that we're passing around the internet all the time today that are in that range. And then another thing that is another wrinkle to that is this other packaging or compiling tool. I don't know exactly what to call it, but it's called Noitka or Nutka. I don't know how to pronounce it, but it actually produces sort of the C code, sort of a C Python compiler. And it will take something that, like that example I was giving you before of like a hello world, and it'll take it down to like 450 kilobytes. When you have examples of something like malware, and then the tools that look at the files that are installed on a machine or look for malware to try to prevent it coming on your machine, they very often want to be able to dive into the code to look for these kinds of things. And so this is going to make it so that, you can't really tell what this thing is and what's happening. And there's actually some different packages that are out there that do this, like kind of like you might have heard of minifying CSS or JavaScript, removing all the spaces and doing things like that. But there's also one called PyArmor, which even does another kind of bit of, binary tricks to it to kind of make it very unreadable to a human or for most machine things. And it's very interesting what's happening there. And beyond that, there's some dangers in Python. There's the eval statement, or the eval function, which you can just run code, which is a little kind of scary for scripts that are out there. And so it goes through all those kinds of things and talks about that, this is a real thing that's happening. And then it gives some real world malware samples. And one of them was this thing called CDuke, which was used PyInstaller. And you might remember the Democratic National Committee, like the DNC hack that happened in 2015 and 16. And
yes.
It was a Trojan horse and a Windows executable that was one of these PyInstaller things. And it was able to do web requests and do some command and control stuff. It's very, kind of wild to think about. And then there's a example of one that happened in Poland, PWO bot, and was able to execute files. And then there's that whole cryptography thing, or crypto mining kind of stuff that can happen. And then they go into a few other ones, but so it's something that's, happening, that's out there in the world. And then it goes in and then talks a little bit further about malware analysis tools, things that can extract a PyInstaller or unpack something like the Py2xe, uncompile and things like that. It's kind of like the flip side of some of the stuff that we talked about last week in that project of things that can kind of create these keyloggers or screenshotting tools and so forth. Again, our plan here of sharing this stuff with you is just to make you aware of that. Hey, there is malware that's out there. And again, I'm still working on getting some security people on here. That's one of my future goals, as I mentioned before. I just think it's an interesting space that's happening. And so I really like the research that was going on in this article.
Yeah, I thought it was a really interesting article and highlighted, for me, I thought one of the most powerful things I got out of that article, just as I read it, was that, one of the things that's driving Python success is how easy it is to get started with Python.
Right.
And that's not just for the good guys, that's also for the bad guys. So that, that ease of getting going and getting started and using Python is also sort of fueling this shift to hackers using Python as their language of choice. So yeah.
Some of the examples that are in there still use, the same kind of techniques. I don't want to call it entirely social engineering, but the idea of, coming in through a Word attachment or, a script that runs, in a Microsoft type of product, or being just a, standalone executable, and us as people in this world, not only us being wary of these things, but to be teaching other people about this other stuff that's out there and to be vigilant in the face of all of that.
Yeah. And there's a couple of things I just want to add, to this discussion. You were talking about the whole idea of like obfuscating code and things like that. We featured several weeks ago now, I mean, back in May and maybe even March, a couple of, this is on PyCoders, a couple of articles about bytecode and decompiling bytecode and things like that. And so I just want to throw a couple of these, they're sort of in the same vein. There was one, this is from PyCoders issue number 421, called Finding Secrets by Decompiling Python Bytecode in Public Repositories. So this is this is a different kind of security issue, but if you're pushing your bytecode, like the .pyc files to GitHub, it could be possible, and you've included, it could be possible that you've got like your AWS secrets and things like that in those, and that those can be decompiled and those secrets can be recovered. And then there was another one about obfuscating opcodes in bytecode. And this is from actually the previous issue, number 420. It's called Remapping Python Opcodes. And it takes you in a whole deep dive into these PYC files, how it's possible to actually obscure and obfuscate the opcodes themselves, and then which could be something that these hackers try to do.
Right.
By the way, so to make it like just where you can't even recover it, but there is a way to remap some of these things and try to pull these things apart and see what's actually going on in some of these obfuscated bytecode files. So, anyways, just some additional things to throw out there.
Yeah, I'll definitely include all those links in there.
Yeah,
to kind of continue the research thread there.
Yeah.
What do you got next?
So the next thing I got is brand new article we released at the beginning of July.
Yeah.
Called Get Started with Django Part 2, Django User Management. So this continues a series that was started a while ago. That part 1 of this is just sort of getting started with Django, where you build a small portfolio application that doesn't have any like user login or anything like that. It's just showing some data. So this now talks about how do you set up user authentication and user management in Django. And it's a really great article. It goes into a lot of depth on that and how to get it all set up. So you learn how to set up the project and what needs to, it walks you through from the very, very beginning. So setting up your virtual environment, getting everything installed, everything you're going to need, getting the settings in your Django app set up properly so that you can get going.
Yeah.
It walks you through doing things like creating a login page, creating a logout page, and the different templates. So there's templates that Django uses that are like expected or there's like default templates and stuff for some of these things. So it walks you through like where those are supposed to live in your project and how you can customize all of that and everything. It deals with how users can change passwords,
Right.
and all of that. And so, there's a template for those kinds of things. Actually, a few templates where they say, I want to change password. You have to put in your old password and then your new one, and then it confirms that you want to change it and all this kind of stuff. How to send password reset links,
Yeah. Nice.
how to reset passwords, and then changing like a user email, things like that, how to register new users. And then the nice thing is it takes you a step further and actually shows you how to integrate with a mail service like Mailgun, which is what's used in this article. There's also SendGrid is another popular one, and it's a similar setup. Yeah, it walks you through the whole process, getting Mailgun set up and everything, so that when a user forgets their password, they can say, I forgot my password. And then it'll actually, they type in their email address. It checks, does a user actually exist with this email address? If they do, then it actually sends them a real email.
Nice.
With a link that they can click on and go and not recover their password, but then create a new password for that. So that's nice. And then the cherry on top at the end is it actually talks about social authentication with a user and how to set up a user, say, logging in with their GitHub account on your application. Yeah, really nice. And it just walks you through step by step. And I like how, again, how detailed it is. And, one of the things when I was learning Django for the first time, and, there's tons of resources out there for Django, but for something as common as user authentication, it seems somewhat difficult to sort of figure out, like, what are all the different templates that I need to be aware of? Where do they all live? How do I overwrite them and customize it? And all this stuff exists in the Django documentation, but it's sort of disparate and like it's not like all together for you. So you just kind of see it like explained.
Yeah.
Here's what all this is. You don't have to go searching for it. And that's one nice thing about this article is it just condenses all that into one source, one reference, and it even shows you like what all the different URLs are that are in the built-in authentication system, and you see them all in one list, and with an explanation of what all these do and everything. So it saves you a lot of time from having to search around through the official docs or combine multiple tutorials that you find to sort of pick and choose things from each. And just really good stuff.
Yeah, I've messed around with this quite a bit. I haven't gone through this article in particular, but all the sort of redirecting that happens, if somebody's not authorized to get to a certain type of thing, and kind of prompting them to log in, and then automatically redirecting them back, or if they log out, all that kind of stuff that happens behind the scenes is pretty intense to a beginner. So it's nice to start off with a part one and get yourself, kind of going in Django and kind of get the idea of like, routes and working as far as getting
right. Absolutely. Yeah.
Just the basics down. And then user management is something, it's a good second level to really get into, because that's one of the most powerful things that I think Django comes with, and one of the things that you would look at using it over something like Flask,
right,
and having to roll your own user management system. So cool. Who's the author on that?
That is Pavel Furtik.
Okay.
I hope I pronounced his name correctly. Yeah.
Nice. So the next one that I have is about f-strings, and it's from Reddit. It's about why would you still continue to use .format when f-strings exist? And in many cases, f-strings really solves a lot of general purpose things that you need to do inside there. And I definitely enjoy using them. And I did a video tutorial based on one of our real Python articles that Joanna created about f-strings. I was using it to do things like, if I didn't have an ORM set up at my work and I was having to like create actual like SQL statements, I was using f-strings in there, and it was allowing me to do lots of sort of replacement things where I was able to then look at this really long, multi-line f-string in this case, instead of just a straight up string, multi-line string. And it would have in brackets all the different variables that I was calling out. And it made it much more readable and easier to use in that way. And, a lot of people, it's hard to change, which I understand that. But so the main ones that I could pull from this whole thread was one thing that even though you can run code inside of the curly braces for your f-string objects, you can't do unpacking of like an iterable unless you go through some interesting hoops to try to do it. They use an example of like a range iterable or a dictionary.
Yeah.
I don't know how often that would come up, but I guess that's something somebody needs to do.
The dictionary thing, I think, comes up somewhat often. I've used that personally before, where you
To unpack though, to use like the asterisk style unpacking.
the double asterisk, where you've got like a dictionary of keys and values, and you want to format into a string some way. Like this key, goes to this value. You put that and just dump it into the string. So normally you would, like the variable, you would assign these all to variable names,
right?
And then pass all those into the format function, and then you would replace those like in order in the function. Well, you could also just do like if you've got a dict where the keys are like the variable names and you've got the values, you can just do format and then asterisk asterisk and then dictionary, and it'll dump all that into the string. So I think that's a fairly common pattern I've seen.
Okay.
But it kind of depends on what you're doing. I mean, if you're already got this dictionary and you're just building it up, then it makes sense to do that. Yeah.
And you could still call them individually throughout the thing as opposed to having just empty curly braces.
Right.
I guess it just kind of changes like how it would look.
Yeah.
The one that I thought was kind of interesting is this idea of a template, if you will, creating this sort of existing string object that is a template that you want to use later, and then applying a format into it for a consistency.
Right.
Doesn't quite work the same way with f strings. It would be a little different in that situation. So I can see that. Translations, that's something that I've heard often, the idea of using other languages and having, it's kind of similar to templating in the sense that you want to have something that can I forget the term for it, where you kind of adjust code for different regions and so forth. To be work, and that's something that's a little harder to do in f strings. Probably the biggest one is anything earlier than Python 3.6,
right? Yeah,
is going to have that problem. So if you're running older versions of Python, and a lot of people who have left Python 2.7 still moved to like 3.4 or something like that, and which is kind of awkward to me. But again, I'm an individual developer. I'm not working with a large team or a large code infrastructure, so it's easy for me to go ahead and jump ahead and use it. And then there's some preference there,
right?
Just some people like the way it looks. So it's a handful of things. One thing that I think is confused occasionally about f strings is the idea that people feel like they can't use a lot of the same formatting techniques of like put 5 spaces or right justify or make it a decimal format. All that stuff still works with f strings.
It does. Yeah.
It just very often in tutorials you don't see it.
Right.
And so we have a good article about that I'll link to show you that, oh yeah, that stuff's still there. That's not unique in the formatting of f strings. So
right.
Yeah.
Yeah. That's I thought that was a really interesting discussion. And you could see, I mean, there were, I think, hundreds of comments on that Reddit thread of people going back and forth talking about, the things they like and dislike about f strings and format and all that. A couple of comments I wanted to add to this. I saw that too, where people were talking about, well, I like to have a template, a string that I can use as a template and then add the data in at some later point for display or for sending somewhere else.
Yeah.
And that is a really good use of formats, as long as the data that you're getting, that you're dumping into that is not coming from a user. It's not coming from outside of your program.
Oh, yeah.
If you've got untrusted data that's coming in and you're using format to put that data into string, you can run into some issues. I mean, you don't know what's in there. It could be evaluating some crazy Python code that does something nefarious.
Right.
And so there's actually another option for templates from the string module in the standard library. There's a template object, which is exactly for this.
Okay.
But it's a safer way of handling code that's coming from handling input
user stuff. Yeah.
Coming from a user somewhere. It's not like being generated from your program, and you know that it's safe. So if you like this idea of templates, but you're using format with user supplied data, you should consider looking at the template object, template class from the string module. That's a safer way to do that. And then another thing that often comes up when you're discussing formatting in F strings is the logging issue. So F strings get evaluated greedily or like immediately. So if you do like your F, string and then colon, some, not colon, curly brace, some variable name, then as soon as Python reads that line, it's executing that F string and producing the string literal, basically. So these interpolated string literals is like this F string idea.
Right.
Sometimes you may have, say, like a something that's being some expression that you're using in the F string syntax that's like an expensive operation. Maybe it's doing some heavy computation, and then returning the result and putting it into the F string. Well, then whenever that F string gets executed, that expensive operation is also being executed. So sometimes you may want to have that string and the operation that's going to get put in the string, but you don't want it executed immediately. And this can be in particular importance when you're logging, especially when you're using like external services to like aggregate logs and things like that. And actually, it turns out that for those types of situations, it can sometimes be better to go back to like the old C style syntax with like the %sign.
Oh yeah. Okay.
Because it doesn't get evaluated immediately. It waits until like the moment that it actually needs to use that string, and then it'll evaluate it there. So just some additional things to consider when it comes to formatting strings.
Yeah, and definitely would be something as far as optimizing code that does a lot of that type of logging and so forth.
Right. Yeah. But I mean, none of this is ragging on F strings. F strings are one of my favorite things of Python 3.
Yeah, I like the thing that added in 3.8 with the equal sign.
Yes, for debugging and stuff. Yeah.
Yeah, for the debugging with it is really, really cool too. So
yeah, that's like if you pass a variable name and the equal sign into your curly braces, then when it prints the string, it'll have the variable name equals and then the value, right? That's what that does, right? Yeah. For people that don't know. Yeah. Yeah. Very cool.
Really handy for like kind of like, if you use printing for, again, troubleshooting or doing your own kind of simple logging system.
Right. Yeah, exactly.
It's pretty nice for that. So this week, I want to shine a spotlight on another Real Python video course. It's designed to help you take your skills to the next level by building projects. And it's titled Grow Your Python Portfolio with 13 intermediate project ideas. The course is based on a Real Python article by Habib Chopaju. In the course, instructor Darren Jones takes you through the importance of building projects, the major platforms you can build projects for with details for command line, web, and graphical user interfaces, 13 different project ideas you can work on, and some tips for working on those projects. I think it's a worthy investment of your time to create projects you can share with others and demonstrate your knowledge. And like most of the video courses on Real Python, the course is broken down into easily consumable sections, and you get additional resources and code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So what do you got next?
Next up, I have got a fascinating article, very long article, called A Beginner's Guide to Robot Programming with Python by Nick McCree. Sorry if I pronounced your name wrong. This is a really interesting, somewhat deep dive. I mean, I'm sure you could go way deeper into robot programming. This really gets you going from the ground up and doing some pretty complex stuff without a lot of complex things going on. So it's a really nice tutorial. The idea here is that you've got a robot that's going to work its way through some world or some map and avoid obstacles to get to some target location. And the beauty of this article is that if you don't have a robot laying around, you can still get up and going because it's got a simulator that you can use. You can download from GitHub, clone a repository that's got a simulator so that you can actually get started and actually see this robot move around a little world and everything. But it can also be adapted to work with physical robots. So if you do have something, you could. It doesn't go into a lot of detail on how to do that. Maybe you can find some research, but it does mention that they got it working with like a iRobot Roomba 2 vacuum.
Yeah, I was thinking
Yeah.
that. I was thinking robot vacuum immediately.
Yeah. So anyway, so it's just really great. I mean, anyone can get started with this, even if you don't have a robot laying around. So I thought that was really cool. And the simulator is called the Sobot Rimulator. and
Okay.
and I'm a fan of spoonerism, so I thought that was I thought that was good.
Yeah, that's good.
But anyways, the article goes into a lot of cool stuff. So it starts off sort of defining like, what are we talking about here? I mean, a robot is a complicated thing. There's a lot to keep track of. So we have to sort of define what we're actually doing here. So it says, okay, first of all, the robot is going to be autonomous. So it's going to move around the space freely all on its own. And we're not going to be controlling it. Basically, we're going to give it like some logic that it can use to navigate, but then we're going to set it off to do its thing and see what happens. And the way that it's going to do that is it's got infrared sensors on it. And I think there's 9 infrared sensors that are arranged like in a skirt. They call it in every direction. So it's covering 360-degree area around the robot. And there's more sensors on the front of the robot than there are on the back, because typically it's more important that the robot has a better idea of what's in front of it than what's behind it. And then it's also what's called a differential drive robot. So it rolls around on 2 wheels. When both wheels turn at the same speed, the robot moves in a straight line. When the wheels move at different speeds, then the robot can turn.
Yeah.
So you're controlling basically the speeds that these wheels are turning with, and that determines like the direction and speed at which or I guess really direction and velocity that the robot's moving.
I think of like controlling a tank.
Right.
Basically the 2 joystick kind of style thing.
Right. Yeah, exactly. So it talks about like there's this API that you use to get information from the robot and then also to control it. And it's really simple. Basically, there's a read proximity sensors function that just returns an array of 9 values that are the values of all the sensors. And then there's a read wheel encoders, which tells you it's like the total number of ticks for each wheel since the start. So you can get some sense of like how the distance that the robot has traveled. And then set wheel drive rates, which you pass it like a velocity for the left wheel and a velocity for the right wheel. And that'll determine how fast the wheels are going and use that to drive it. So there's really just 3 things you got to know here. It's real fairly simple, but you got to know how to translate sensor readings into meaningful information. So he talks about a little bit about the simulator and what it does, and it applies some physics rules to the robot's movements. It considers things like collisions with obstacles and then providing new values for the robot's sensors. So that's what the simulator is doing. If you have a real robot, then this doesn't apply, right? It's just gathering the information, but this is what the simulator does for you. And it takes a very simple model and approach to this. So makes assumptions like the terrain is always flat and even. Obstacles are never round. They always have corners. The wheels don't ever slip. They've got perfect traction. Nothing's going to come and like push the robot around.
Okay.
Sensors are never going to fail or give false readings. And the wheels are always going to turn when they're told to. So those are some assumptions like in the simulator that you can't assume that in real life, right? I mean, the robot vacuum's got to know like, man, the dog may just come and start playing with
there
this
may
thing.
Be stairs.
Or there may be stairs. Or I may get stuck, and then my one wheel just stops responding because a whole bunch of hair got caught up in the bearing or something and it won't turn. So anyway, it puts together kind of a simple model for you to get started, and then just goes on from there to walk you through setting this up and how to read the sensors and how to translate them into data. And anyway, it's just really cool article that it's got all this there for you. And again, my favorite thing about it was that you don't actually have to have the robot. It's got this Sobot Rimulator that you can you can use to get started.
Yeah, cool. One of my first like toys I was like super excited about, and this is going to really show my age, was the Big Track. I don't know if you remember that. It was like a little
I
robot
don't.
tank. It was a little robot tank, and like an add-on you could get for it would be so it was called the Big Track was the name of the tank. It looked like something out of Battlestar Galactica, which was like on TV at the time.
Yeah.
It had a little gun. It was like, it'd fire a little light beam, and you would basically tell it where you wanted to go. So you had to pre-program it, which is kind of like, I think, how a lot of basic robot programming toys probably work today, where you're like, okay, go forward 3, turn left 2, and it's very logo-ish. And then it had this dump truck kind of like add-on thing, and so you could have and it would basically plug into the back of it, and then you'd give it a command to like, okay, dump the stuff out of it, so you could sort of deliver things to people in the house or something like that, and have it drive around and like, dump the thing out and then come back. And I don't know, it was a fun toy. But this makes me think about that too, the idea of like
Yeah.
a minimal set of variables, and the idea of like, the idea of turning, and how those little robot vacuums kind of do that, and how they kind of navigate, even though you're saying basic, sort of square type geometry, but even just going around a corner, and trying out different techniques.
Right.
A neat way to kind of build from there. So yeah, I like that. That sounds really cool.
Yeah.
So my next thing is a real Python article from Geron Yella, who was our first guest on the podcast. He has spent quite a while creating this article about Python import, and the subtitle of it is Advanced Techniques and Tips. And oh boy, this is a really in-depth article. It goes way beyond the basics. And I've done a tutorial, a video course on importing, and it goes over all the kind of the basics that you should know, how to make a package, modules, and how they're loaded, and namespaces, and this does all that. It goes there to kind of start with, but then it really jumps into, well, what's really happening with namespaces and creating namespace packages, what can happen as far as the sort of collisions that can happen if you were to like write your own math module and import it,
Right.
and then try to use built-in stuff, and then how that can sometimes behave inconsistently, where there's like the time module that actually doesn't get overwritten in that way, which is really kind of interesting. And he goes into that and sort of solutions for that sort of stuff. The trouble of reloading modules. This was really fascinating to me. There's a import lib resources, and I had never really thought about that sort of stuff, like that you can have that be part of your importing, and how you would handle things like image files or text files or CSVs, and how that can be handled in this really kind of elegant way, and how you want to import stuff. And then kind of going back to your thing you're mentioning about the print statements, how you sometimes may want to delay when that happens.
Right.
Because it may take a certain amount of time, and how that can be triggered to, okay, now it's going to do the CSV load, and have that happen dynamically. How to debug what's imported. This goes back to something you talked about a couple weeks ago, which was running script packages into zip files.
Oh yeah.
And how that kind of can happen. He goes into that. He gives examples for all of these things and code to check it all out. Extending the Python import system, handling different versions of packages. And then he has this really great, one of the first times I worked with him was on the decorators article that he has, which is really excellent also.
Right.
And he has this whole plugin system that he talks about, which is something he's kind of passionate about. And he's talked about in a few different talks. I think he revisits it again in his PyCon 2020 tutorial, not just a talk, but it's like a couple hour long tutorial on decorators. And in this case, he's talking about how to then import that plugin architecture and use it in there. It's just a really great resource if you want to know what's going on with importing, and you have confusions about namespaces, confusion about how Python checks the different resources for where things can be imported from. It goes into all that sort of stuff. I think it's just a really, really well researched and very detailed deep dive. I had to come back to it multiple times because it's very, very long and detailed. So
it's definitely something you would like. I mean, if this were in book form, it would be like the reference book, kind of. I mean, it's not written like a reference book. It's a
No, it's
more
very approachable.
approachable style. Yeah, but
Yeah.
still, it's just the amount of things that's in there. It's just something you'd kind of keep on your desk and like, wait a second, I there's something in there about this. Let me just open it up and find it real quick. But yeah, I mean, it's pretty comprehensive. I
Yeah.
think that's a good way to describe it. It takes you from zero to hero, as they say,
Yeah.
and covers stuff that, I mean, stuff that I'd never even brushed up against
Yeah.
before in my own.
I mean, there's a whole section, obviously on packaging, on, pip, and, how to have it sort of, sort of install from your local system,
Mm-hmm.
which is kind of interesting kind of thing to sort of mock what's happening there. I mean,
Right.
it's really, it just kept going. I was like, wow, okay, that's cool.
Yeah.
So,
Yeah.
nice.
Yeah. Really good stuff.
Yeah. So we're going to keep going with this theme of having projects at the end here. And what's the project you wanted to talk about this week?
Well, last time you had me on, we had a little bit of discussion about functional programming.
Yeah.
I think that was from last time that I was on. That was we talked about I think the reduce
Yep.
function that Leodanis written
Mhm.
that article. Yeah. So I came across a package. I don't think it's a particularly new package, but it was the first time I'd come across it. It's called toolz with a Z, toolz, and you may have heard of the itertools package in the standard library and the functools module. These, it's sort of in the spirit of these. So there is a itertools. So toolz is a package, and it's got an itertools with a Z module, a functools with a Z module, and then also a dicttools, which
Okay.
are some functional programming operations on dictionaries. And you might think, well, I've already got an itertools and a functools in Python, the standard library, so why would I need something like this? Well, this goes way beyond the stuff that's in those built-in modules, and it has some sort of unique things in it. So, for example, in the itertools module, there is a function called unique, which can take any iterable and return an iterator over the unique values in
Okay.
that
Sort of
iterable.
set like functionality.
Sort of like set, but when you do the set, like if you've got a list of numbers like 1 1 2 3 3 4, then when you call the set function on that list, it returns a set with 1 2 3 4 in it, just the unique values.
Right.
But it's computing that set immediately and returning you this set object. So what this does unique is, let's say you have a gigantic iterable, like you're reading the lines in some just insanely large file,
Yeah.
and you've got an iterator over the lines in that file, and you just want to get the unique values from those. Like each line contains a single value maybe, and you want the unique ones. Well, rather than returning like a list and having to build that list in memory of all the unique files, or a set in memory, it returns an iterator that you can use. So you can save a lot of memory overhead when you use something like this. That's the whole point of these like itertools and everything, is it's dealing with iterators rather than these like iterables. Well, an iterator is iterable, but something like a list or a tuple or a,
Right. It's not going to take up as much of the memory footprint, and
it's just going to get one thing at a time, use it, and then discard it, and then get the next one, use it, discard it.
cool.
Yeah. So the unique thing is something that you don't find in itertools. It's also got like a frequencies function, which it'll return an iterator over the frequencies of, or actually no, this one doesn't return an iterator. Sorry, it just returns a dictionary of frequencies. So this is actually kind of related to the counter.
Yeah. Counter.
From
I was
the
thinking that.
thing, but it's a little bit different API. But yeah, it's just got all sorts of stuff in here, and the same thing with tools. So functools in the standard library, you might know it for there's a popular. I say it's popular. I don't know actually how often people really use this, but the LRU cache decorator.
Yeah.
Have you heard of that? Yeah.
Yeah, I have.
So that's I think something that's used quite a bit from that. So if you got a function, you can memoize the function basically where if you have the function is like an expensive function that does a lot of computation and can take a long time. Well, it can cache that, hey, when these values are given to me, this is the value that I calculate. So it has to be what we would call like idempotent, like basically, for like if you give it the same values, it's always going to return. Like give it the same input, it's always going to return the same output.
Sure.
But you can cache like, hey, for this input, this is what the output is. So you only have to compute it once, and then the next time it sees that input, it's just going to return the value because it already knows what it is. So that's something from the built-in functools module. Well, there's a memoize function in this one that does something similar, but then it goes way deeper than that, and it's just got all sorts of stuff for working with functions. And then it's got the additional thing, the dict tools. So it's got like a merge function for merging two dictionaries, a merge with, other kinds of like ways to create new dictionaries from old dictionaries, all sorts of dictionary operations. So yeah, really interesting package. It's got a lot of cool functionality in there.
Yeah, I mean, it sounds like you're talking about it being more memory efficient, and if you're using these types of stuff, and then it kind of goes back to the whole functional concept of like, I'm guessing it doesn't have the side effects and so forth that we were talking about before too.
Right. Yeah, correct. It's really, so it's described as a set. Well, it's described as a set of utility functions for iterators, functions, and dictionaries. But a lot of this stuff has kind of a functional flair to it. Yeah, there's some things, especially in the iter tools and func tools packages here, that sort of smack of functional programming there.
Cool.
Yeah.
So my project is called Python Keyboard. I'll give you two links to it, but one is, it's a hand-wired USB and BLE, Bluetooth Low Energy keyboard.
Okay.
That's powered by Python. And so in it, they go through this whole project of actually wiring the keyboard, creating the columns and the rows, and adding the different keys. In this case, they're using these cherry switches that you might have heard of that are popular for the tactile, mechanical clicky keyboards. And it's an interesting project. And then what they've done with it, they wire it up to they have a guide for hand wiring it. What they've done after that fact, and the group is called makerdiary.com. And they've kind of gone a little further and created what they call the M60 mechanical keyboard. And it's basically an open source USB BLE 5.0 modular, hot swappable keyboard. So you can basically change out the keys. And right now it's in sort of a pre-order state for their PCB board. But the article before that is how to kind of create it yourself if you wanted to wire this thing up yourself and kind of create this prototype. And it's just very interesting. And then you might say to yourself, well, what's the advantage of doing something like this? Well, it's using CircuitPython to do the programming underneath it. So that means that when you plug it into a USB port, you then can reprogram how you want the keys to function, what keys are doing what, where. You can create macros, you can create all kinds of elaborate stuff that you could, basically program this keyboard to do much more interesting stuff, which I think is pretty cool. And
all in Python.
Yeah, all in Python, which is pretty powerful. So if you're interested in, number one, mechanical keyboards, but the idea of creating a project that you can kind of reprogram what this keyboard is going to do and how it behaves and so forth, it's very cool. And then the whole Bluetooth thing is very cool also. And, I've been talking about MIDI off and on very often. And so these projects always intrigue me as to like additional projects that I can think of for programming my own controllers for like musical projects, or in some cases, like if you're not familiar with it, but there's this program called Ableton, which is like a loop based sort of music production thing. And I could kind of think of like creating a big controller with these like lit up mechanical switches that, would change color depending on what kinds of things I want. So I'm like thinking to myself, this would be kind of a cool thing, not just for like a QWERTY style keyboard, but for kind of a controller, or, people that are into games. I could think of some really powerful stuff you could do with it for reprogramming it too.
Yeah. So you looked more deeply into this than I did. So do you, I guess they're selling some of the parts to build this, or eventually?
Yeah. So it starts out with, several months ago, they started to build this Python keyboard, and they show actual wiring it with this,
Yeah.
the ground wires and then kind of creating the matrix of that. And I was like, wow, that looks really intense. And then what they've done on their site, the makerdiary.com, is they started to make an open source PCB board, which is, basically it looks like a big flat board, but it's hot swappable that you can actually put your keys into it and then get it to respond, and it will have the circuitry ready to go for it. And so I haven't ordered one, but I'm looking at it, and they have this whole story about, kind of going back to it and, how it can behave. It's a USB-C, type C.
Yeah.
And then, along with the Bluetooth low energy, and then they showed like kind of the key mapping stuff in Python, and it's pretty cool. It's a neat project.
Yeah.
I'm always intrigued by these things. So
yeah, I mean, I just thought it was, I found this originally for PyCoders, and, kind of clicked around a little bit on the GitHub repo and thought, well, this just looks really, really cool. But I didn't realize they had like the store and everything. And
yeah.
So yeah, it's, I guess they've got it on sale for pre-order, like $39 for this PCB. And then you could just buy your own switches and keycaps and go to town on it. Yeah, that's really cool.
Yeah. So thanks for coming on again and sharing all these articles with me.
Yeah, thanks for having me. Always enjoy it.
All right. Talk to you soon.
See ya.
I want to thank David Amos for coming on the show this week and bringing along all those great articles. And I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.